Hello everyone, this is Prasad. On behalf of Unacademy, I welcome all of you to another session on hybrid electric vehicle. In previous lecture, we have understood different types of DC to DC converters. We are half done. We have understood non-isolated DC to DC converters. In that, we have understood buck converter, boost converter, and buck boost converter. Buck converter is used to reduce the DC voltage from one level to the other. Boost converter is used to boost the DC voltage, and buck boost converter can be used for both the configuration. Along with that, there is a cook converter and spice converter, which are not much used. Mostly we are preferring the buck and boost converters. Now let's understand further the isolated DC to DC converter. Now what is meaning of isolated? In case of isolation DC to DC converter, you are specifically using a transformer that will help you to isolate two electrical circuits operating at different voltage levels. So in most of the application, isolation is used between the converter input and output, and this isolation is obtained using transformers. That was I told you. So high frequency transformers are used so that size is reduced. There is always a relation between the frequency and the size of equipment. Okay, you will be shocked to know the supply frequency of aeroplanes, spacecrafts, or the planes which take you from one city to the other. The supply frequency inside the aeroplane is around 400 hertz, and the supply frequency in India for household, it is 50 hertz. Why this is difference of frequency? Because when you increase the frequency, size of the machine reduces, and as size of the machine reduces, you can have lower weight, and as lower weight is there, less fuel is required to move the machine. That's why the high frequency transformers are used, so that you can limit the size, and as you are reducing the size, the weight of the transformer is going to get reduced, and hence overall impact on the weight of the vehicle is going to get reduced. So such a multiple converters can be used to get multiple DC outputs possible by adding multiple secondary windings. You can add more and more transformer windings to get more and more secondary output voltages. And it is very important to have proper turns ratio. Now what is turns ratio? If you see transformer, if I want to show you in simple language, this is the transformer primary winding, this is core, and this is the transformer secondary winding. Now this winding is having n1 number of turns, this winding is having n2 number of turns. Okay, so primary is the one to which we connect the supply, and secondary is the one across which we connect the load. Okay, so the number of turns, or the turns ratio is what? It is n1 divided by n2, where n1 are primary number of turns and n2 are secondary number of turns. So the turns ratio should be chosen properly so that you can obtain the desired voltages. Also, if you see further, we have already done with the linear, that is shunt and series kind of converters, which are not used in electric vehicles because they are only step down converters and there are a lot of losses in that. We have understood the buck boost, and cook converter, and now it's time for us to understand the isolated converter. There are four types of isolated converter. One is the full bridge, other is the forward, third is the push pull, and fourth is a flyback converter.